Hi guys, welcome to the Skill Learn. So today we are going to discuss about three-dimensional conduction equation in Cartesian coordinates or rectangular coordinates. So without wasting time, let's get started. So before going to the derivation, there are the three assumptions. So the first one is physical properties are constant with respect to temperature. For example, viscosity, density, specific heat, etc. are the physical properties. And the second one is physical dimensions are constant. Then the third one is uniform heat generation throughout the system. So these are the three assumptions, and moving to the derivation. So consider a small elemental material having sides dx, dy and dz, and it is placed at the coordinate axis x, y and z. So as you can see in the diagram, the material is homogeneous and isotropic. So the K can be defined as the thermal conductivity of the material, rho is the density of the material, C is the specific heat of the material, Qg is the heat generated per unit volume, and the Qx, Qy and Qz are the rate of heat flow with respect to x, y and z direction. So this was the introduction, and moving to the main derivative part. So the energy stored can be found by using following steps. So we know that Fourier law can be defined as the Q is equal to minus K into A dt by dx, which I have explained it in a previous video of Fourier law of conduction. You can check it out as link is provided in the description. And the stored heat is equal to inlet minus outlet. Here the Qx is the heat entering inside the element in x direction, and Qx plus dq is the heat at the outlet, and the term dq is the heat or energy present inside the element. So as you can see in the diagram, here is the Qx which is entering inside the heat, and the Qx plus dq is the outlet. So dq is the main term which is the outlet, and it is the heat present inside the element. So therefore Qx minus Qx plus dq, and the bracket, and it is written in the bracket. So by opening the bracket, Qx get cancelled, and minus dq is the remaining one. So multiply by dx in both the sides. So dq minus dx divided by dx is the remaining one, and it is marked as the equation 2. Therefore the net heat flux in x direction is q net is equal to minus dq by dx into dx. And here as we have discussed earlier, that q is equal to minus k into a dt by dx, so we have to place that here in this equation. So therefore minus d by dx into minus ka dt by dx into dx. So here minus minus get cancelled, and the remaining one is the k into a d square t divided by dx square into dx. And here a is the area which is being defined as length into breadth. Therefore k into dy by dx dz, as you can see in the diagram, that dy is the height and the dz is the breadth. So the final solution for the heat flow in the x direction is k into dx into dy into dz into d square t divided by dx square. Similarly, the net heat flux in y direction is k into dx into dy into dz into d square t divided by dy square. Only the change is here, instead of dx square we have to replace it by dy square, and similarly in z direction we have to replace it by dz square. So heat generated within the volume, that is dx, dy and dz, is qg into dx into dy into dz. And the rate of change of heat capacity of the body, which can be also defined as the energy stored, is equal to the mass into specific heat into dou T divided by dou T. Therefore is equal to rho into dx into dy into dz into C into dou T divided by dou T. By energy balance equation, energy in minus energy out plus energy generation is equal to energy stored. So by considering the similar things in equation 3, 4 and 5, that is k into dx, dy and dz. So by taking it common, the equation is written as k into dx dy dz into d square t divided by dx square plus d square t divided by dy square plus d square t divided by dz square plus qg into dx dy dz, which is the heat generated within the volume, and the rho into dx into dy dz into c into dt by dx is the energy stored, which is also called as the rate of heat change capacity. So by taking dx dy dz common, both sides we can cancel it, and the remaining one is k into d square t divided by dx square plus d square t divided by dy square plus d square t divided by dz square plus qg is equal to rho into c into dt by dx. And here dividing by k in both the sides, therefore the last equation is d square t divided by dx square plus d square t divided by dy square plus d square t divided by dz square plus qg divided by k is equal to rho c divided by k into dt divided by dt. And here alpha is equal to k divided by rho c, which is called as the thermal diffusivity. Therefore the last equation is d square t divided by dx square or d square t divided by dy square or d square t divided by dz square plus qg divided by k is equal to rho c divided by k into dt divided by dt. And here in last equation, rho c divided by k is written as 1 divided by alpha. So this was the final answer of this equation. So if you guys like this video, please like, share and comment and subscribe. And if you have any doubts, you can ask me in the comment section. So thank you guys.